Good day, ladies and gentlemen. You're all very welcome to this week's technical session of the CNPS. Now, today we are proposing to come to the last part of this multi-part series presented by Vladimir Netchitailo on his world-universe model. It's hard to believe, actually, the time has flown so quickly, because we started in the springtime, and we're planning to host an 8-part series with just one break, slightly before the middle. We're now in the final straight, actually, the part 8, which will be the Hypersphere world-universe model, part 8, classical physics. Now, the description is basically that classical physics is principally different from quantum physics that describes quantum objects such as which have 4 momenta only. However, classical physics is dealing with ensembles of quantum objects with an exclamation mark. This is basically what Vladimir says. So WUM, the world universe model, introduces classical notions when a very first ensemble of particles was created and become possible to introduce notion medium of the world. We discussed the most important concepts: space, time, gravitation, cosmological principle, universality of physical laws, law of the conservation of angular momentum, stretching of the world, content of the world, formation of galaxies and large-scale structures, speed of light in vacuum, origin of cosmic microwave background radiation. So this will have covered a complete panoply of elements comprised in the WUM. We basically started looking at cosmological objects and very, very far away nebulae and so on, and then we came in to our own galaxy, and then we came into the Milky Way, and the last 2 sessions we've been talking about Earth properties. So we're now looking maybe at an interface between the world universe model and classical physics, which is most interesting. Now, having gone through the preliminaries, I regret to say that for the very first time we've had 7 talks, and Vladimir has always, although it's 7 a.m. in the morning in California where he is based, he's always been there 15 minutes early. He's been there always before I arrived, actually. But unfortunately, he hasn't got there. And I think, let me see now. Yeah. I'm going to post, before I forget, because this is the most important, the link for today's green room session. Let me see now what's happening. Did I get it there? I'm not sure what that was. I must have pressed the wrong button. Sorry, just a second. Okay. So at least we have that out now. However, in my email, Vladimir was asking, where am I? And I was asking the same question about him. So he is around. There's some gremlin there. Let me just see what he's saying. He says yes, he's there. Well, why hasn't he logged in? I don't see you. I don't see you. Sorry. Nor do I see you. Send. So Vladimir, our speaker today, is trying to get in, and he thinks he's in, but he cannot see me. He cannot see the session, and I cannot see him. So there's some problem at the moment. I don't know. Don't know what we can do about it. Very, very odd. Sorry about this, ladies and gentlemen. Yeah, no response at the moment. Where do I see you? Yeah, I'm expecting him to come in any moment now. No. Yeah, I don't understand. We have quite a number of people in the green room now, and Vladimir hasn't logged in, and he's asking where we are. So I don't know how to resolve this. Okay, let me see now. Please send me the right link. Well, okay. So perhaps he was having the same problem that some have had, such as James Keane, where their computers remember the last session and they can't get into the present one. Although Vladimir has never experienced this problem up till now, but I've actually put in today's link, so let's hope he can get that. Tell him to sign in and then re-sign in. Yeah. Well, let's see. Does his clicking on the direct link get him anywhere? Perhaps sign out and then sign in again. I'm surprised because normally there have been absolutely no problems with Vladimir's access. This is the very first time. Email Vlad the direct link. I've done that, James. I've done that. I don't know what's happening. I really don't. Wait a minute, there's another memo in. No, nothing. Well, there's another comment in. Let me just see. Yeah, and I just comments. Well, gentlemen, perhaps I'll ask for your help. I'm rather confused now what to do, and I don't know whether we should maybe start discussing some subject or we've waited for him for 10 minutes now, and although he seems to be sending emails, he's not in.
I think he'll be in a couple of minutes. I sent him a couple of emails myself.
Okay. Well, we can give him another couple of minutes.
Did anyone try David's email from last night and have problems? That's what I sent him when I got it yesterday.
What do you mean, Nick? Try his email. What did you say? David's email from yesterday.
No, I was saying that David sent out an email yesterday, and that's what I sent to Vladimir. And I'm just wondering, when this morning I signed in by the email that came 15 minutes ahead of time, and I had no problem getting in.
Yeah. So
but
David,
I wonder if the previous one had a problem. I just sent him the specific ad URL with everything spelled out.
I sent him the specific URL, but if it's absence of having received David's normal announcement, that's the problem. That was a generic email, so perhaps we should
not being able to come
send him that.
You
see, David's announcement only went out some hours ago because he was away on vacation and without access to a computer. I understand. So maybe Vladimir hasn't received that, but I've sent him the generic email. Maybe I'll see. See now. Very odd.
Yeah.
But David's thing would have gone to him anyway. I'll forward it just to be sure. Private chat, more things. Oh yeah, okay. We have Quest here today. You're welcome. Maybe he should start his computer.
Yeah. I think restart.
Vladimir's a bit of a dab hand. I mean, I'll say that, but he usually doesn't need advice. But I'll say that. I'll send him an email to that effect. I'm not even sure if he's getting these emails because he responded to me by replying to an earlier email, not replying to my email that I just sent him. somebody came in and then disappeared. I think it might have been he. I didn't
No,
get to it.
I think it was me.
Oh, it was you, was it?
I
Okay.
think so.
Yeah. Yeah. This is this is not really acceptable, and our social media participants are sending some mails, and they're probably getting a bit impatient, which is understandable. So I think
Actually,
we can't really wait much longer, gentlemen. What do you think?
yeah. Actually, Quest asks an interesting question. He says, "What does anyone make of Vladimir presentations thus far?" And
The 7 previous presentations.
7 previous ones, yes.
Yeah.
My take is that he spent 23 years reading extremely broadly and looking at all of the empirical evidence and found a number of inherent problems, um, and then came up with a thesis that addressed those problems. So I don't claim that necessarily every single word that he has said is valid, but it seems to me that this is a very big step forward and should stimulate a lot of thinking. And he himself calls for that. So I think
He's
it's
just
been great.
arrived, Nick.
Oh, great.
So thank you. I might actually take the liberty of even repeating some of those observations. So, Vladimir, I don't know what the problem was there.
I used your last link and it works. For some reasons, the previous ones were corrupted. I've done everything what I could do, but unfortunately didn't help. The very last link was exactly what I needed.
And I was sure it was. But I sent that link to you about 5 minutes ago, just by responding, by sending an email. I don't think you were getting those emails because the email you sent to me was actually replying to the earlier email to David.
I'm very sorry. Yes, I replied to you, and I've got 7 your letters. 7 of them.
Okay.
That's why no problem. It was some corrupted link. I don't know why it didn't work for me. And the last one, immediately I'm with you.
Okay. Well, that is a problem, as I have announced on previous occasions. I think it was brought to our attention by Jim Keane that his computer, no matter what he did, if he tried to wipe everything, it always brought him to last week's presentation.
Yes,
or
the last
quarter,
week it was exactly the point to to Robert to the link, not mine.
So your computer has a mind of its own. It's changed its mind, decided not to update.
It is the very last your session, my presentation, and it happened with me some issue with the whole system.
Okay. Well, anyway, the important thing is we have you here to give us the final part of your 8-part session on the womb. And I said earlier on that the time has really flown. We started in the springtime, and we had this session going on for 8 parts with just one break in the middle. And we're now coming to the final part. And actually, in your absence, we did start very briefly a discussion. Nick made some observations because a new participant in the green room, Quest, has said to us, Jerry Harvey actually has said that what were our takes from your previous 7 parts of presentations. So Nick was just saying, how it's really pretty all encompassing, but maybe we have to be a bit careful and so on. So we'll come back to that in the discussion. So we've only we've spent a little more time, and I hope we don't take up too much of your talk or indeed the Q&A. So, as usual, Vladimir will be projecting. I take it, Vladimir, you will, as usual, the same for the previous
Yes,
parts. You'll be projecting things, going through it, and this time you're dealing with classical physics. I suppose the intersection of your work with classical physics,
exactly.
and I'm going to give you the complete control of the floor and so on, and I'll be here if you need me. So,
Okay.
would you like to bring your slides up before I put myself down, because I have to bring them up as well.
I'll do it now.
Yeah. Yeah.
Can you see it?
Yes, yes, yes. It's up now. So now that it's up, I can go, and I'll leave it completely up to you. It's your show now, Vladimir.
Thank you so much for your patience and for some troubles. At last we are together. Classical physics is the branch of physics that should be described by classical notions, which define emergent phenomena. An emergent phenomenon is a property that is a result of simple interactions that work cooperatively to create a more complex interaction. Physically, simple interactions occur at a microscopic level, and the collective result can be observed at a macroscopic level. The developed hypersphere world universe model introduces classical notions when the very first ensemble of particles was created at the cosmological time about 10 to the minus 18 seconds, and become possible to introduce the notion medium of the world. In WUM, space, time, gravity, temperature, mass are all emergent phenomena. There is a basic size unit about 10 to the minus 14 meters in classical physics, no less. We emphasize that classical physics is principally different from quantum physics that describes quantum objects which have four momenta only. Classical physics is dealing with ensembles of quantum objects. According to contemporary physics, classical physics, pre-1900 physics, is a group of physics theories that predate modern, more complete, or more widely applicable theories. Modern physics, post-1900 physics, incorporates elements of quantum mechanics and relativity. How classical physics can incorporate elements of quantum mechanics in modern physics? I don't get it. To be clear, I would like to provide a couple examples. Kinetic theory of gases explains microscopic properties of gases, such as pressure, temperature, viscosity, thermal conductivity, and volume, by considering their molecular composition and motion. In 1859, Maxwell formulated the Maxwell distribution of molecular velocities, which gave the proportion of molecules having a certain velocity in a specific range. This was the very first ever statistical law in physics that defines macroscopic properties of gases as emergent phenomena. The temperature of the ideal gas is proportional to the average kinetic energy of its particles. The temperature knows nothing about movement of each particle, and particles have kinetic energies only. They have no idea about the temperature. In 1965, Penzias and Wilson discovered cosmic microwave background radiation. According to Big Bang model, about 380,000 years after Big Bang, temperature of the universe fell to the point where nuclei could combine with electrons to create neutral atoms. As a result, photons no longer interacted frequently with matter. The universe became transparent, and MBR was created. The photons that existed at that time have been propagating ever since, though growing fainter and less energetic, since the expansion of space causes their wavelengths to increase over time. These photons are the same photons that we see in MBR now. But then, why is MBR is perfect black body? What is the mechanism of photons wavelengths increasing over time and growing fainter and less energetic? According to WUM, wavelengths is a classical notion. Photons, which are quantum objects, have four momenta only. They don't have wavelengths. By definition, black body radiation is thermal electromagnetic radiation within or surrounding a body in thermodynamic equilibrium with its environment. Black body spectrum of MBR is due to thermodynamic equilibrium of photons with the intergalactic plasma, the existence of which is experimentally proved by fast radio bursts. Space and time. There is no doubt that we cannot develop any scientific concept about the physical world without establishing a primary idea of space and time. Newton's primary notion of space and time is documented in his Principles of Mathematics. Euclidean space is a fundamental space of geometry intended to represent physical space. Originally, it was a three-dimensional space of Euclidean geometry. Minkowski space is a combination of three-dimensional Euclidean space and time into a four-manifold where the space-time interval between any two events is independent of the internal of inertial frame of reference in which they are recorded. Although initially developed by Minkowski for Maxwell equations for electromagnetism, a mathematical structure of Minkowski spacetime was shown to be implied by the postulates of special relativity, because it treats time differently than it treats three spatial dimensions. Minkowski spacetime differs from 4D Euclidean space. In WUM, the world is the hypersphere of 4D nucleus of the world, which is in fact a 4D bubble with a low density in the present epoch. It is expanding in its fourth spatial dimension. As a result, the hypersphere is evenly stretched. All points of the hypersphere are equivalent. There are no preferred centers or boundaries of the world. A hypersphere is an example of three-manifold, which locally behaves like a regular Euclidean 3D space, just as a sphere looks like a plane to small enough observers. 3M finite boundless world has a spatial measure, radius of the curvature in the fourth spatial dimension R. All spatial parameters of the world can be measured relatively to R. Any cosmological model of the infinite universe has no spatial measure. WUM introduces absolute cosmological time tau measured from the beginning of the world 14.22 billion years ago, like the absolute temperature T measured from the absolute zero in kelvins. It is principally different from the solar time T, which is defined by the parameters of the solar system, and cosmic time of the general relativity. It is defined by the impedance, wave resistance, of the medium that equals to the Hubble's parameter H. Cosmological time equals to inverse value of H. It marches on at constant pace since the beginning of the world until the present epoch, and defines the age of the world according to this equation. All time varying parameters of the world can be measured relatively to the absolute age of the world. Time is not a physical dimension in the absolutely different entity than space. Time is a factor of the world. In our everyday life, we use an alleged space 3D Euclidean and solar time T. Medium of the world. Timeline of luminiferous ether. 17th century, Robert Boyle was a proponent of an ether hypothesis. According to Boyle, the ether consists of subtle particles, one sort of which explains the absence of vacuum and the mechanical interactions between bodies, and the other sort of which explains phenomena such as magnetism and possibly gravity that are otherwise inexplicable on the basis of purely mechanical interactions of macroscopic bodies. Say 1690, Huygens' treatise on light theorized that light is a wave propagating through ether. 1704, Isaac Newton publishes Optics, in which he proposes a particle theory of light. This had trouble explaining diffraction, so he adds a fudge factor, claiming that an ethereal medium is responsible for this effect, and going further to suggest it might be responsible for other physical effects such as heat. 1727, James Bradley measured stellar aberration for the first time, proving that light has a finite speed as well as that the Earth is moving. 1818, Augustin Fresnel introduces the wave theory of light, which proposes light is a transverse wave traveling in an ether, thereby explaining how polarization can exist. It is important to note that both Newton's particle theory and Fresnel's wave theory both assume an ether exists, albeit for different reasons. From this point on, no one even seems to question its existence. 1904, Hendrik Lorentz publishes a new theory of moving bodies without discarding the stationary electromagnetic ether concept. 1905, Henri Poincaré shows that Lorentz's theory fulfills the principle of relativity and publishes the Lorentz transformations. His model was still based on Lorentz ether, but he argues that this ether is perfectly undetectable. 1905, Albert Einstein publishes an observational equivalent theory, but complete with a derivation from principles alone, leaving the ether aside. Einstein also emphasized that this concept implies the relativity of space and time. He later labeled it special relativity. Following the work of Young and Fresnel, it was believed that light propagates as a transverse wave within an elastic medium called luminiferous ether. At that time, it was realized that ether could not be an elastic matter of an ordinary type that can only transmit longitudinal waves. Unique properties of ether were discussed by McCulloch in 1846, who proposed a theory of rotationally elastic medium. The potential energy of deformation in such a medium depends only on the rotation of the volume elements and not on their compression or general distortion. This theory produces equations analogous to Maxwell equations. McCulloch's ether can transmit transverse waves. He has this to say about the ether. The constitution of the ether, if it ever would be discovered, will be found to be quite different from anything that we are in the habit of conceiving. Though at the same time very simple and very beautiful. An elastic medium composed of points acting on each other in the way supposed by Poisson and others will not answer. Luminiferous ether was abandoned in 1905 by special relativity. The Friedmann equations were first derived in 1922 from Einstein's field equation for the Freeman-Lemartrier-Robertson-Walker matrix and a perfect fluid with a given mass density ρ and pressure P, which is a medium of the universe. The medium exists or not? It turned out that abandoning the luminiferous ether was crucial for classical physics. It is a great pity that the mainstream physicists at that time didn't know or forgot a theory developed by McCulloch in 1846. In later years, there have been classical physicists who advocated the existence of ether. Nikola Tesla declared in 1937 in prepared statement on the 81st birthday observance, all attempts to explain the working of the universe without recognizing the existence of the ether and the indispensable function it plays in the phenomena are futile and distant to oblivion. Paul Dirac stated in 1951 in article, "Is there an ether?" that we are rather forced to have an ether. WM is based on Maxwell equations, and McCulloch's theory is a good fit for the description of the medium. The model introduces the medium of the world composed of stable elementary particles, protons, electrons, photons, neutrinos, and universe-created particles. The existence of the medium is a principal point of WM. It follows from the observations of intergalactic plasma, MBR, far-infrared background radiation. According to WM, intergalactic voids discussed by astronomers are in fact examples of the medium at its purest. The medium is the absolute frame of reference relative to MBR rest frame. The Milky Way galaxy and the Sun are moving with the speed of 552 and 370 kilometers per second, respectively. Then there is no need in frames of reference of special relativity. The total energy density of the medium is 2/3 of the total energy density of the world in all cosmological times. All macro objects are built from the same particles. The energy density of macro objects adds up to 1/3 of the total energy density throughout the world's evolution. Medium of the world is the savior of classical physics. Don't throw the baby out with the bathwater. Dark matter. The history of dark matter can be traced back to at least the end of the 18th century. In 1783, John Michel was the first to propose the existence of dark stars. He suggested that there might be many dark stars in the universe and proposed that astronomers could detect dark stars by looking for star systems which behave gravitationally like two stars, but where only one star could be seen. It was an extraordinary accurate prediction of binary systems in which a dark star and a normal star orbit around their center of mass. Bertone and Hooper in 2018 provide an excellent review of dark matter history. In 1844, Bessel argued that the observed proper motion of the stars Sirius and Procyon could only be explained by the presence of faint companion stars influencing the observed stars through their gravitational pull. In 1904, Lord Kelvin was among the first to attempt a dynamical estimate of the amount of dark matter in Milky Way. His argument was simple yet powerful. If stars in Milky Way can be described as a gas of particles acting under the influence of gravity, then one can establish a relationship between the size of the system and the velocity dispersion of the stars. Henri Poincaré was impressed by Lord Kelvin's idea of applying the theory of gases to the stellar system of Milky Way. In 1906, he explicitly mentioned dark matter and argued that since the velocity dispersion predicted by Kelvin's estimate is of the same order of magnitude as that observed, the amount of dark matter was likely to be less than or similar to that of visible matter. Universe created matter. In WUN, dark matter is dark when astronomers observe the world with telescopes only in the visible spectrum. The contemporary astronomy allows us to observe the world in wavelengths from radio waves up to gamma rays. Then they are not dark at all. The first known binary system was Cygnus X1, 1971, that is typically the brightest persistent source of hard X-rays with energies up to 60 kiloelectron volts. In 2000, Minchin et al. Discovered binary galaxy system Virgo HI21 with NGC 4254, which has a 21 centimeter emission. Bohm proposes multi-component universe-created matter system consisting of two couples of co-annihilating UC particles, a heavy UC fermion, UCF1, with rest energy 1.3 tera-electron volt, and a light spin zero boson Dirac 70 mega-electron volts, that is a dipole of Dirac's monopoles with charge mu E slash 2 alpha. E is the elementary charge, and alpha is a dimensionless Rydberg constant that we will discuss below. A heavier fermion UCF2, 9.6 giga-electron volts, and a line spin zero boson LOP, 340 kiloelectron volts, that is a dipole of preons with electrical charge E slash 3, UCF3, 3.7 kiloelectron volts, UCF4, 0.2 electron volts, and at last boson Xion, 5.3 microelectron volts. The reason for this multi-component UC matter system was to explain the diversity of very high energy gamma ray sources in the world, the diversity of UC matter cores of macro objects of the world, superclusters, galaxies, and extrasolar systems, which are fermion compact objects, and UC matter reactors in WUM. UC particles do not possess an electric charge. Their masses cannot be directly measured by mass spectrometry. Hence, they can be observed only indirectly. The signatures of UC particle self-annihilation with expected rest energies from 1.3 tera-electron volt to 5.3 microelectron volt are found in spectra of diffuse gamma ray background and the emissions of various macro objects in the world. We connect observed gamma ray spectra with the structure of macro objects, nuclei, and shells compositions. Self-annihilation of those UC particles can give rise to any combination of gamma ray lines. Thus, the diversity of very high energy gamma ray sources in the world has a clear explanation. Gravity. In 1687, Newton published a groundbreaking book called Mathematical Principles of Natural Philosophy, in which he described gravitation as a universal force and claimed that the forces which keep the planets in their orbits must be reciprocally as the squares of their distance from the centers about which they revolve. Lesage's theory of gravitation is a kinetic theory of gravity originally proposed by Fatio in 1619 and later by Lesage in 1748. The theory proposed mechanical explanation for Newton's gravitational First, in terms of streams of tiny unseen particles, which Lesage called ultramundane corpuscles, impacting all material objects from all directions. According to this model, any two material bodies partially shield each other from the impinging corpuscles, resulting in a net imbalance in the pressure exerted by the impact of corpuscles on the bodies, tending to drive the bodies together. Lesage proposed quantitative estimates for some of the theory's parameters. He called particles ultramundane corpuscles because he supposed them to originate beyond our known universe. It was a genius prediction of universe-created particles, xions, in WUM. The distribution of ultramundane flux is isotropic, and laws of propagation are similar to that of light. He suggested that the ultramundane corpuscles might move at the speed of light. To maintain mass proportionality, ordinary matter consists of cage-like structures in which their diameter is only the 10 millionth part of their mutual distance, so the particles can travel through them nearly unhindered. In order to achieve exact mass proportionality, as in Newton's theory, the ultramundane flux must be infinitely intense. Lesage theory is the very first theory which defines the gravity as an emergent phenomenon. In WUM, the time-varying gravitational parameter G is proportional to the energy density of the medium. It is not a constant. This is why WUM aligns gravity with Lesage's theory of gravitation. WM gives for Lesage's theory the following parameters. Xions, 5.3 microelectron volts, are ultramundane corpuscles which created by the universe. Xions are ultra-relativistic UC particles. Proposed weak interaction between xions and matter provides mass proportionality. Energy density of xions in the world, about 64% of the total density, provides high intensity of their flux. Gravitational mass mg is a classical notion that defines gravity, the emergent phenomenon. We emphasize that an inertial mass mi, that is a coefficient of proportionality between a force and acceleration, has nothing to do with mg. Albert Einstein developed his general relativity starting with the assumption that the inertial and passive gravitational masses are the same. This is known as the equivalence principle. In WUM, gravity is not an interaction, but a manifestation of the medium. Emergent gravity, space, and time. Barcelo et al. In 2011 have this to say about emergent gravity. One of the more fascinating approaches to quantum gravity is the suggestion, typically attributed to Sakharov, that gravity itself may not be fundamental physics. Indeed, it is now a relatively common opinion that gravity, and in particular the whole notion of space-time and space-time geometry, might be no more fundamental than fluid dynamics. The word fundamental is there used in a rather technical sense. Fluid mechanics is not fundamental because there is a known underlying microphysics, that of molecular dynamics, of which fluid mechanics is only the low energy, low momentum limit. In WM, the medium of the world is not fundamental and has macroscopic parameters like in fluid mechanics, impedance, gravitomagnetic parameter, energy density, etc. time and space are closely connected with medium's impedance and gravitomagnetic parameters. It follows that neither time nor space could be discussed in absence of the medium. The gravitational parameter G, that is proportional to the medium's energy density, can be introduced only for the medium filled with matter. Gravity, space, and time are all emergent phenomena. WM confirms the supremacy of matter, postulated by Albert Einstein. When forced to summarize the theory of relativity in one sentence, time and space and gravitation have no separate existence from matter. Maxwell equations. Maxwell equations form the foundation of classical electrodynamics. Gravitomagnetism is a gravitational analog of electromagnetism. Gravitomagnetism equations, different from Maxwell equations by some constants, were first published by Heaviside in 1893 as a separate theory expanding Newton's law. Gravitomagnetism is an approximation to Einstein's gravity equations in the weak field limit. Thirring pointed out this analogy in his On the Formal Analogy Between the Basic Electromagnetic Equations and Einstein's Gravity Equations in a first approximation paper published in 1918, shortly after the first paper of Einstein. The value of Maxwell equations is even greater because Swain showed that linearized general relativity admits a formulation in terms of gravitoelectric and gravitomagnetic fields that closely parallels the description of the electromagnetic field by Maxwell equations. We emphasize that gravitomagnetism considers not only interactions between masses, but also between mass currents, which produce gravitomagnetic field. In 2021, Ludwig, in the article Galactic Rotation Curve and Dark Matter According to Gravitomagnetism, wrote, most theories used to explain the rotation curve have been restricted to the Newtonian potential framework, disregarding the general relativistic corrections associated with mass currents. The effects attributed to dark matter can be simply explained by the gravitomagnetic field produced by the mass currents. The explanation of galactic rotation curves made by Ludwig is in a good agreement with WUM. Fundamental physical constants. Maxwell equations were published by Maxwell in 1861. He calculated the velocity of electromagnetic waves from the value of an electrodynamic constant C, measured by Weber and Coleridge in 1857, and noticed that the calculated velocity was very close to the velocity of light measured by Fizeau in 1849. This observation made him suggest that light is an electromagnetic phenomenon. We emphasize that C in Maxwell equations is the electrodynamic constant, but not the speed of light in vacuum. It is worth noting that the speed of light in vacuum, commonly denoted as C, is not related to the world in our model, because there is no vacuum in it. Instead, there is the medium of the world consisting of stable elementary particles. Rydberg constant R infinity is a physical constant relating to atomic spectra. The constant was arose in 1888 as an empirical fitting parameter in the Rydberg formula for the hydrogen spectral series. Electron charge to mass ratio E over ME is a quantity in experimental physics. It bears significant significance because the electron mass cannot be measured directly. The E over ME ratio of an electron was successfully measured by Thomson in 1897. We name it after Thomas, RT. Planck constant H was suggested by Max Planck in 1901 as a result of investigating the problem of black body radiation. He used Boltzmann's equation from statistical thermodynamics that shows the relationship between entropy S and the number of ways the atoms or molecules of a thermodynamic system can be arranged. Kb is the Boltzmann constant. Based on the experimentally measured values of these constants, B infinity, RT, CR, and the magnetic constant mu0, we make measurable the most important constant as follows. Basic size units, it uses all these experimentally measured parameters that equals about 10 to the minus 14 meters. Dimensionless Rydberg constant, alpha. Electron rest energy, elementary charge E. All these fundamental constants, including classical electron radius A0, could be calculated based on the experimentally measured constants before quantum physics. It is worth noting that the constant alpha was later named fine structure constant. In WUM, we introduced the following basic units: size, time, energy, surface energy density, based on these fundamental constants. Dirac large number hypothesis. In 1937, Paul Dirac, in the paper A New Basis for Cosmology, said, it is proposed that all the very large dimensionless numbers which can be constructed from the important natural constants of cosmology and atomic theory are connected by simple mathematical relations involving coefficients of the order of magnitude unity. The main consequences of this assumption are investigated, and it is found that a satisfactory theory of cosmology can be built up from it. The gravitational constant will be inversely proportional to the epoch. WUM follows the idea of time-varying G and introduces a dimensionless time-varying quantity Q that is in effect the Dirac large number, which in present epoch equal to about 10 to the power 40. G can be calculated from the value of the parameter Q. According to these equations, WM holds that there indeed exists simple mathematical relations between all primary cosmological parameters that depend on Q. Newtonian parameter of gravitation, age of the world's radius of curvature in the fourth spatial dimension, Hubble's parameter, critical energy density, concentration of intergalactic plasma, minimum energy of photons, temperature of the microwave background radiation, temperature of the fine infrared background radiation peak. In frames of WUM, we calculate the values of these primary cosmological parameters, which are in a good agreement with the latest results of their measurements. Creation of matter. In 1964, Hoyle and Narlikar offered an explanation for the appearance of new matter by postulating the existence of what they dubbed the creation field. In 1974, Paul Dirac discussed continuous creation of matter by additive, uniformly throughout space, and multiplicative mechanism proportional to the amount of existing matter. WM, the 3M world, which is a hypersphere of 4D nucleus, was started by a fluctuation in the eternal universe. 4D nucleus is expanding in its fourth spatial dimension, and its surface, the hypersphere, is evenly stretching. The radius of the nucleus r is increasing with the speed c, gravitodynamic constant, for the absolute cosmological time tau from the beginning and equals to r equals c tau. The surface of the nucleus is created in a process analogous to sublimation. Continuous creation of matter is the result of this process. Sublimation is a well-known endothermic process that happens when surfaces are intrinsically more energetically favorable than the bulk of a material, and hence there is a driving force for surfaces to be created. UC matter is created by the universe in the 4D nucleus of the world. UC particles carry new UC matter into the 3M hypersphere world. Ordinary matter is a byproduct of UC particle self-annihilation. Consequently, a matter-antimatter asymmetry problem discussed in literature doesn't arise, since antimatter does not get created by UC particle self-annihilation. By analogy with 3D ball, which has a two-manifold sphere surface that has surface energy, we can imagine that 3M hypersphere world has a surface energy of the 4D nucleus. The proposed is 4D process responsible for the expansion, creation of matter, and error of. It is the main hypothesis of WM. In our view, the error of the cosmological time does not depend on any physical phenomenon in the medium of the world. It is the result of the 4D nucleus of the world expansion due to the driving force for surfaces to be created. It is important to emphasize that creation of matter is a direct consequence of expansion. Creation of UC matter occurs homogeneously in all points of the hypersphere world. Primary notions. Principle of relativity is the requirement that the equations describing the laws of physics have the same form in all admissible frames of reference, including inertial forces. For example, in the framework of special relativity, the Maxwell equation have the same form in all inertial frames of reference. In the framework of general relativity, Einstein's field equations have the same form in arbitrary frames of reference. In WUM, this principle is valid because the medium of the world is an absolute frame of reference. Then there is no need to discuss special relativity and general relativity, which abandoned in the ether in 1905. We can use the well-known equation considering time-varying physical parameters. Universality of physical laws is the notion that the spatial distribution of matter in the universe is homogeneous and isotropic when viewed on a large enough scale, since the forces are expected to act uniformly throughout the universe and should therefore produce no observable irregularities in the large-scale structuring over the course of evolution of the matter field that was initially laid down by Big Bang model. In WUM, this principle is valid because the medium of... I'm so sorry. Yes. In absolute framework, then there is no need to discuss special relativity. It's okay. I'm so sorry. Let me continue the next paragraph. In WUM, this principle is valid at the cosmological times over 10 to the minus 18 seconds because physical laws are determined by the medium of the world, which is homogeneous and isotropic and consists of elementary particles with 2/3 of the total matter. The distribution of macro objects with 1/3 of the total matter is spatially inhomogeneous and anisotropic and temporally non-simultaneous. And therefore, this principle is not viable for the entire world. Conservation law states that a particular measurable property of an isolated physical system does not change as the system evolves over time. Exact conservation laws include conservation of mass and energy, conservation of linear momentum and angular momentum, and conservation of electric charge. One particularly important result concerning conservation laws is Noether's theorem, which states that there is a one-to-one correspondence between each of one of them and a differentiable symmetry of nature. Conservation of energy follows from the time invariance of physical systems. Conservation of linear momentum follows from the space translation invariance translation along x, y, z directions. Conservation of angular momentum follows from the rotation invariance, rotation about x, y, z axis. In my opinion, angular momentum problem is the killer of all existing cosmological models, including Big Bang model. Old timers of cosmology should solve this problem. In WUM, conservation laws are not exact conservation laws because the world is not an isolated physical system and is continuously getting, you see, matter from the eternal universe. Maxwell equations form a foundation of classical electromagnetism and gravitomagnetism. Gravity Einstein's field equations are nonlinear Maxwell equations, which should be used in a strong field limit. In Maxwell equations, there are no notions of elementary charge and energy, but there are charge density and energy density. Maxwell equations produce only two physically measurable quantities, energy density and energy flux density. The proposed new primary notions are, in fact, a paradigm shift in classical physics. Main results of WUM. Summary of the calculated by WUM in 2013 cosmological parameters and experimentally measured parameters are presented in the following table. Gravitational parameter calculated in 2013 were measured in 2018 with the same accuracy. Hubble's parameter in 2021, ionized baryons in 2016, minimum photon energy in 2017. We emphasize that WUM allows for precise calculation of values that were only measured experimentally earlier and makes verifiable predictions. I mean, MBR temperature, it was measured in 2009, and far infrared background temperature peak, it was measured in 1998, but calculated by us in 2013. The discovery of a supermassive compact object at the center of our galaxy, Nobel Prize in Physics 2020, made by Hensel and Gass, is a confirmation of one of the most important predictions of WUM in 2013. Macro objects of the world have cores made up of the discussed dark matter particles. Other particles, including dark matter and baryonic matter, form shells surrounding the cores. GWST discoveries confirmed the most important predictions of WUM in 2018. Absolute age of the world is 14.22 billion years. Dark epoch spanning for Laniakea supercluster from the beginning of world for 0.45 billion years, when only you see matter macro objects form and evolve. Luminous epoch ever since 13.77 billion years for Laniakea supercluster, when luminous macro objects, superclusters, galaxy, extrasolar system, etc., emerge. Transition from dark epoch to epoch to luminous epoch is due to explosive rotational fission of overspinning surface speed at equator exceeding escape velocity, UC matter, superclusters cause, and self-annihilation of UC particles. Macro objects of the world form from the top superclusters down to galaxies and extrasolar systems in parallel around different cores made up of different UC particles. 3M finite boundless world presents a patchwork quilt of different luminous superclusters which emerged in different places of world at different cosmological times. Explain problems. WUM solves a number of physical problems in contemporary cosmology and astrophysics through UC particles and their interactions. Angular momentum problem in birth and subsequent evolution of galaxies and extrasolar systems explained by volcanic rotational fission of overspinning UC matter superclusters cause. Hubble tension explained by observation of galaxies which belong to different superclusters. The value of Hubble's parameter should be measured based on cosmic microwave background radiation only. Missing baryon problem related to the fact that the observed amount of baryonic matter didn't match theoretical predictions solved by the calculation of the concentration of intergalactic plasma. Fermi bubbles, two large structures in gamma rays above and below galactic center, are stable clouds of UC particles, UCF1, UCF2, and UCF3, containing uniformly distributed UC matter objects in which UC particles self-annihilate and radiate gamma rays. Galaxies are ellipticals and spirals due to an explosive rotational fission of their overspinning UC matter cores. Coronal heating problem relates to a question of why the temperature of the solar corona is millions of degrees higher than that of the photosphere. According to WUM, the origin of the solar corona plasma is not coronal heating. Plasma particles, electrons, protons, multi-charged ions are so far apart that plasma temperature, in the usual sense, is not very meaningful. Plasma is the result of the self-annihilation of UC particles. The solar corona, made up of UC particles, resembles a honeycomb filled with plasma. Cores of Sun and Earth rotate faster than their surfaces, despite high viscosity of the internal medium. WUM explains this phenomenon through absorption of UC particles by cores. UC particles supply not only additional mass proportional to tau in power 3 over 2, but also additional angular momentum proportional to tau squared. Cores irradiate products of self-annihilation which carry away excessive angular momentum. Solar wind is the result of this mechanism. Internal heating of gravitationally rounded objects in solar system is explained by UC matter reactors inside of all macro objects fueled by UC particles. Internal heating is due to UC particles self-annihilation. Diversity of gravitational rounded objects in solar system is explained by UC matter reactors inside of macro objects fueled by UC particles. All chemical elements, compositions, radiations are produced by macro objects themselves as the result of UC particle self-annihilation in their different UC matter cores. Plutonium-244, with half-life of 80 million years, exists in nature. It is not produced by the nuclear fuel cycle because it needs very high neutron flux environments. Any plutonium-244 present in the Earth's crust should have decayed by now. In WUM, all chemical products on the Earth, including isotopes K4, Calcium-40, Uranium-238, Thorium-232, and Plutonium-244, are produced within the Earth as the result of UCF1 self-annihilation. They arrive in the crust of Earth due to convection currents in the mantle carrying heat and isotopes from the interior to the planet's surface. Expanding Earth's hypothesis asserts that the position and relative movement of continents is at least partially due to the warmth of Earth increasing. In WUM, the Earth's UC matter core absorbs new UC particles, and its size is increasing in time proportional to root square of tau. Hence, there is an expansion of UC matter core, and its surface, the upper mantle with crust, is stretching. Due to UC particle self-annihilation, new chemical elements are created inside of the upper mantle with crust. As a result, the relative movement of continents is happening. Faint young sun paradox describes the apparent contradiction between observations of liquid water early in Earth's history and the astrophysical expectation that the sun's output would be only 70% as intense during that epoch as it is during the modern epoch. In WUM, all macro objects of the world were fainter in the past. As their UC matter cores absorb new UC particles, the sizes of macro objects and thus their luminosity are increasing in time proportionally to tau. Considering the age of the world, 42 billion, and the age of the solar system, 44.6 billion years, it is easy to find that the young sun's output was 67.6% of what it is today. Matter-antimatter asymmetry problem. Ordinary matter is a byproduct of UC particle self-annihilation. This problem does not arise since antimatter does not get created by UC particle self-annihilation. Black body spectrum of microwave background radiation is due to the thermodynamic equilibrium of photons with intergalactic plasma. Unidentified infrared discrete emission bands with peaks 3.3, 6.2, 7.7, 8.6, 11.2, and 12.7 micrometers explained by self-annihilation of UC particles UCF4 with rest energy 0.2 electron volts. Solar corona, geocorona, and planetary coronas made up of UC particles resemble honeycombs filled with plasma particles, electrons, protons, multi-charge ions, which are the result of UC particles self-annihilation. Lightning initiation problem and terrestrial gamma-ray flashes are explained by the self-annihilation of UC particles in geocorona. Ball lightning are objects that have cores made up of UC particles surrounded by the electron-positron plasma shells contaminated by chemical elements of soil and air as a result of terrestrial gamma-ray flash strikes of the ground. WUM predicts a new phenomenon, a generation of ball lightnings according to the proposed model of them. Once we master the creation of ball lightnings in a controlled environment, we can concentrate our efforts on harvesting that energy from a practically infinite source, the medium of the world with UC particles. Conclusion. Hypersphere world universe model is consistent with all concepts of the world. The model successfully describes primary cosmological parameters and their relationships. WUM allows for precise calculation of values that were only measured experimentally earlier and makes verifiable predictions. The remarkable agreement of calculated values with the observational data gives us considerable confidence in the model. Great experimental results and observations achieved by astronomers in the last decades should be analyzed through the prism of WUM. Considering the GWST discoveries, successes of WUM, and 87 years of Dirac's proposals, it is high time to make a paradigm shift in cosmology and classical physics. Acknowledgements. I'm always grateful to academician Prokhorov and Professor Manenko, whose influence on my scientific life has been decisive. I am eternally grateful to my scientific father, Paul Dirac, who was a genius and foresaw the future of the physics in new cosmology. I am forever grateful to Nikola Tesla, who was a genius. I am much obliged to Professor Korda for publishing my manuscripts in the Journal of High Energy Physics, Gravitation, and Cosmology. I am grateful to Nick Percival and Harry Ricker for valuable comments and suggestions, which have led to an overall improvement of the presentation. Special thanks to my son Ilya, who helped me clarify model and improve its understanding. This is the end of my very last presentation. Thank you so much for your patience and your participation in my presentation. I'm ready for your questions now. Thank you.
Well, many thanks once again. And in the summary, we'll note, what we have for posterity, basically, in the recorded presentations for these 8 parts. But actually, as usual, Vladimir, you've kept very accurately to your hour, and the 23 minutes or so is basically represents the messing around at the beginning we had, owing to difficulty in communications. So I hope we'll have some time to go through some of the questions here and maybe get contributions from a number of the people in the green room. I see we have quite a number of people here today. So let's, as usual, try to go through the questions very quickly, omitting those which are not specifically germane to today's presentation. So I'll try to do that quickly now. Okay. Talk about quantum levels and so on. I think most of it has been discussions between maybe 3 or 4 persons here, Cornelis and Quest and CERN and so on. I've tried to answer 1 or 2 questions myself, like, how did Maxwell arrive at his equations and so on. It was a mathematical, encapsulation of experimental facts. Okay. Well, just general questions asking, does Vladimir accept the concept of ether as valid? Could I just add to that? Maybe take these two questions together, because I had a question. You know, with regard to looking at the constitution of the ether, you've talked about the other things, you know, like solar corona and so on, being composed of things like UC particles. And I'm wondering, would you conceive of the ether as being constituted of similar particles? Or what do you think of things like Simone's Epola model? So basically, what is your model of the constitution of the ether?
The constitution of ether, I exactly told you that it is an ordinary matter. We know about protons, electrons, neutrinos, and protons, electrons, photons, and neutrinos, and a lot of many of universe created particles. That's it. This is a composition. What is important? Usually, ether is like a liquid or some gas or something like this, and nobody put some specific participants of the ether. My intention was to make it measurable, experimental, that I know about the particles that constitute my medium.
All right. Well, let me see. Is there anything that we might hold an up and I don't know if Robert K is referring to you. He says, does he know that energy density is equivalent to a pressure?
In classical physics, you have some, you can see that
it basically is, I suppose. Yeah.
There is a correlation between energy density and pressure. Yes, but it's classical physics. Everybody knows from university.
Yeah, indeed.
Forget about the quantum physics. It's above or out of classical physics. And what is important, even these numbers, these notions, they took from classical physics and transferred them to quantum physics. I don't know any other notion in quantum physics separate from the classical physics.
Okay. Understood the nature. Okay. Now, there have been a number of things coming in on the private chat, and they might be a lead into our discussion with your agreement. So James Keane has started talking about points about the continuous versus the discrete space, and he basically thinks perhaps that you have an attachment, maybe an undue attachment to continuity. So he's made a number of points here. So maybe with your permission, Jim, I'll bring you up to allow you to make those points directly, because we can't actually project the comments from the private chat onto the screen.
Hello. Hi, Vlad. Thanks for your presentation.
Hello, James. As usual. Thank you so much for
coming. What if somebody said, these are friendly questions, if I may say so. What if someone said that your definition of these different kinds of UCP, universe UC particles, is merely a result of observation of the peaks in the radiation spectrums that you described? In other words, the data show peaks, and you then assign a particular type of UCP to each peak. What if someone says that? What would be your response?
Let me tell you, the beginning of my model was exactly this way. I found my relations and I saw some peaks in gamma radiation and I tried to get them with alpha only. Why alpha only? Because my intention was to build the model based on two parameters only. And there is a Q parameter I found immediately, and the other one is alpha only. And alpha must be constant only because universe it's eternal. It cannot produce something variable. It should be something constant. That's why I didn't have a choice. And when I saw a few of them matching the experimental peaks, then I started to think about what else might be. And all these particles, they are active participants in all these experimental observations. That's why all of them match some experimental results, different one. And in particular papers, I published all this matching with experimental results. Even in my second presentation, I gave you some examples of gamma ray spectra and peaks that matching my multi-component UC matter. That's why, the development of my model is 24 years. The very first paper I put on Vixra, it was 11 years after that. And at that time already I knew a lot about cosmology, but it was not the end of the story. It was the very beginning. The end of the story is right now. And I will tell you why. Because even this very great, very special, very great communication with Harry helped me to myself to rename even my dark matter. It's now universe created matter. He put this attention to me, guy, you don't have dark matter. You have something else in your model. And he was exactly right. That's why, even during this presentation, I developed the last point of my model. And the last point was universe matter. That's why I have my good experience with questions and with participants that they initiate me to think about one more time about the most important notions of my model. And this is the last point and critical point in my model. You see created matter initiated by Harry. I'm very glad to thank him very much for this, participation and moving me in the right direction.
For Harry, yeah.
So,
So Jim.
Go ahead, Ian.
No, just anything further. I'm just really prompting you.
For each peak, you're postulating a particular fundamental UCP particle. Is it possible that the different radiation peaks that you
You're breaking up a bit,
Jim. Something happened to communication.
Have reported and summarized. Is it possible that these peaks could be created by a smaller number of more fundamental particles rather than simply assigning a fundamental particle to each observed peak? Did you get that question? Because it looked like we were cut off for a second there.
You're right. Usually experimentalists, they're measuring not peaks. There is some broadband radiation. Gamma radiation, it's not peak. You have some interaction, some different angles and all this stuff. I don't want to talk about the detail. It is some kind of bands. And people, they're trying usually, based on some experimental results observed, to calculate the mass of dark matter that might be. My approach totally different. I proposed some universe created matter, this value, and I advise people, astronomers, to try to observe to analyze their gamma rays spectrum through the prism of my numbers. Do you know this table of chemical elements by Mendeleev? You have some different numbers, from this table. I propose them the same table of particles, and please do your best and analyze your results if you can explain them through the prism of all of them at once, because it's 18 orders of magnitude difference from the maximum to minimum. That's why you have so many opportunities to iterate your gamma ray spectrum and to find the right numbers, the right participants of this spectrum.
So could you just say a quick word? Sorry, Jim, but maybe it might help in this context. Cornelis has said, so basically, quick word, Vladimir, how is UC matter created and why in the different kinds? Just a very quick word on that, maybe.
Yes, so I put, by the way, in my even report that this process, how it creates, is the main hypothesis of my model. Eternal universe, I told you the last time, it's like a god. I don't know how he's doing. I'm sorry for this comparison. It's not right, but it's close to. That's why this process, how it creates, I have no clue. We don't have any particular properties of the universe. We know only this is a creator in our world of all these particles. That's it. This is my main point. That's why even this question to the eternal universe, for me, it's meaningful. No,
it's philosophy, really, more than science.
Everybody wants to know, but then immediately you will ask the question: what is the universe? What are the characteristics? What are the parameters? It's a 4D or 5D entity, and so on and so on. No, it's not the right way to go. There is something like a hypothesis. By the way, compare with the different hypothesis of Big Bang. We have this initial singularity. Where it came from? What is going on with it? What is the initiation process? And so on and so on. That's why any theory, it has some hypothesis. And this is the main hypothesis of my model, creator. But for me, fluctuation by creator, much better than infinite, infinite energy density of initial singularity. It's it, because I'm a physicist. I like fluctuation, not infinities.
So, gentlemen, we have suggested boldly on previous occasions that the two of you gentlemen get together and maybe exchange views. I don't know if that's something in the future or have you started it yet, but it seems to me that you're complementary, as I think you yourself observed, Jim, on a previous occasion.
Yeah, well, thank you, Ian. Yeah, I'd be happy to correspond with Vladimir more in the future, and would welcome any emails from him. I've sent him some of my thoughts. Lastly, if I just may, if it seems to me that you're saying that a process that you call self-annihilation of UCPs causes radiation, particularly gamma rays. And that, so the question is that how does this then result in the formation of ordinary matter such as protons, electrons, and neutrons, etc.?
It's a very good question, and I hope that astrophysicists will talk about this mechanism, how it goes, and so on and so on. Let me remind you that the very first paper was published by Nobel Prize laureates in physics in 1987, and they proposed this mechanism. They had some different name of their dark matter particles, but they proposed this gamma radiation based on annihilation of these particles. I am not an expert in this business. On the contrary, I invite all the people based on my model to develop the theory of these processes.
Okay, well, thank you. Perhaps
I will be more than happy.
Okay.
Thank you. Perhaps there are other people who
if we could, thank you very much, Jim.
Thank you very much for your questions.
We're going to be a bit short today because I want to give Vladimir a little time to summarize, and I want to say a few words myself, as this is the last part. So we may be a little short today. But if there's anybody else in the green room who wants to speak now, perhaps he'll raise his hand. Denny has raised his hand, and then Harry. So I'll bring Denny up first.
Thank
hello,
you.
Denny. What's your contribution.
I just wanted to mention that this is sort of ties in with what Vladimir seems to be saying. Giorgio Toro, who measured the ether drag with a couple of pendulum experiments, one with pendulums of the same mass but different shapes, so they would have different characteristics because the ether, according to him, is partially entrained by matter. And so it's like when matter moves through it, it's sort of like friction. And he has a new paper out on cosmology where he tries to explain the fact that the galaxies rotate at the wrong speed and so on, using the fact that there's the ether drag, and the ether also has a certain amount of mass, and so all these things you got to take into consideration. You get some interesting looking results about cosmology, and I think Vladimir also includes the ether in solving the problem of why the galaxies aren't rotating at the right velocity and so on. And so Toro, you might want to look up his papers. They're on academia.edu. And I think Ian has also proposed that the ether is partially entrained by matter, by the Earth, for example, but he never went on to design an experiment to measure the drag, which is what Toro has done. That's all.
Are you familiar with any of that work, Vladimir?
No, let me stress one very important point. Many times I told you already. Ether, it's the medium in my model. Why I named it the medium? Because ether, if you will calculate energy density of ether, so named ether, it is 30 orders of magnitude less than the energy density of water. What kind of liquid, what kind of ether we can talk with you about if the energy density is 30 orders of magnitude less than water? What kind of physical interactions you can measure with so rarefied gas? It is not liquid, perfect fluid, as it was in general relativity, and so on and so on. It's an absolutely wrong idea. It is not liquid. It is not. It's a rarefied medium consisting of particles I named with energy density 30 orders of magnitude less than water. That's it.
Well, Toro claims to have, he has these pendulum experiments and he's detected it, even though it may be, the energy density may be very small. He's detected it using just pendulums in a vacuum, of course, so that
there is no vacuum. It is impossible to measure, as I told you. So rarefied gas that there is no friction of it. You cannot even introduce this,
Well, Ian believes also he's done research work showing that the ether is partially entrained by the Earth. Isn't that right, Ian?
Yes, I would say that. It's almost totally entrained by the Earth, but you have to take into account tidal forces, which militate against that being 100% entrained. Yes, and I think with the pendulum thing, Denny, isn't it that the bob was sort of oriented in different ways, and he was getting a differential effect on the.
Well, there were bobs with the same mass but different shape. One was more aerodynamical, you might say, than the other, and sure enough, that's what happened when he ran it for quite a while, I guess, and at the end of the experiment, it was definitely concluded that the ether was dragging the different pendulums, but at a different rate.
But whatever about that, Denny, is there any disagreement, Vladimir? I mean, do you think that the Earth doesn't basically entrain the ether?
You know, of course, no. As I told you, 30 orders of magnitude less than water. No, how can I'm a physicist? I'm not a mathematician. I cannot even imagine how we measure any parameter with such accuracy. 30 orders of magnitude. Come on.
30 orders of magnitude.
I don't know.
Well,
Because I propose, these particles based on physical phenomena like fast radio bursts, intergalactic plasma, and all this stuff. You know what? Let me give you some idea about this medium. We have 1 proton per 4 cubic meters. This is a distance between protons even in my medium. That's why what we're talking about, how we can measure this, in any experiments, all this influence of ether. There are
But
some
of course,
other
you measure
scientific
macroscopic
experiments.
properties such as electric permittivity, magnetic permeability, impedance of the ether. You measure things like that.
You know what? No, but what is important, even in parameters right now, there is some in 8 or 9 digits after the comma change of impedance of our medium. Because, even idea of a vacuum, it doesn't work. Even this perfect liquid, it doesn't work. And they measured this parameter and then found some difference. In one of my papers, I named this paper. I told, look, it's not 1. It is 1, 0, 0, 0, and the number 10 after digit, it will be 1. That's why I'm a little bit, I'm trying to tell only the truth. I'm experimentalist. I don't believe in any physical interaction with the medium with energy density 30 orders of magnitude less than water. I don't know how to measure it. Maybe people they know. I don't.
Dayton Miller measured the ether velocity. There's velocity through the ether in some high altitude experiments. Which followed the Michelson-Morley experiment, which they claimed was a null result, but actually was not, as Ian pointed out in one of his articles.
Okay, we are talking the same story. I cannot tell you anything about my opinion. I'm a physicist, and I'm an experimentalist, first of all. My education was laser physics, laser physicist. I'm optical guy. I know what I'm talking about. Sorry.
Well, it's something that might be worth considering further. I mean, we've raised these points. Denny has raised these points and given some indications, and how it fits in or doesn't fit in with your ideas might be something we can investigate further. So, if that's all right, Harry had his hand up, and I'd like to bring him in now. Is that finished, Denny, for the moment?
Yes,
I would say we come back to it because you've raised.
Thank you so much for your information. I didn't know about it.
Thank you, Denny.
I didn't know about it.
I think we might not have the time after this, but let me just see. Harry had his hand up. Harry, you had a point you wished to make, or points.
Yeah, I see that something's wrong with my camera. I've got a big red green band in my front of my face. Okay, I see that you did include some of my comments in your summary at the end, which I thought was good. I have one of my main comments, and I think we've already seen this already in the discussion so far, is what they call TMI, which is too much information. And I'm afraid, you provided a lot of ammunition. You provided a lot of ammunition for people who don't want to believe your theory to attack it and destroy it by the fact that you've got too much stuff that you've talked about in your presentations. This discussion about the ether is a good example of that. I mean, somebody who is a physicists believe in dogma, okay, and they don't listen to each other. They accept the dogma. So they don't listen to new ideas, okay? That's one of the things I've learned over the years. And if you read comments about people in science, you'll see in private, they'll tell you that, and sometimes you'll see it in writing. Okay, so that's a problem, I think. Too much opportunity for people to find mistakes or things they disagree with. too much information, but it's all there. You did a good job. I love this idea of universe created particles. I like the idea that you have these massive objects. They obviously exist in the centers of galaxy. They obviously exist in stars. They are obviously producing solar systems and planets. I mean, you're on the right track, I think. The problem is you're dealing with a lot of dogma and a lot of bad physics. Okay. Because I looked into some of the issues that you raised, just a few of them, not all of them. One of them is, where does the solar system come from? And you know what? I found out they don't really have a theory on that. It's all BS. Where did the moon come from? Well, this planet called Theia came out of nowhere and smacked into the earth and created the moon. That's not science. Okay. So you've given people an opportunity to come up with actual, real scientific theories. I think this is an opportunity to do that, and I congratulate you for that. I do have a comment or a criticism, and that is you don't talk about magnetism. Magnetism seems to be one of the most important forces in the universe, probably more important than gravity. The current science establishment is completely gravity oriented. Everything is caused by gravity. But when you look at the world, everything involves magnetic fields. The sun, the sunspots, galaxies, everything has strong magnetic fields. It's highly influenced by magnetism. Nothing in the scientific theories address magnetism as having anything to do with the creation of stars and galaxies and planets. So, but you don't really talk about it much. So that's my main criticism, and I'll stop there.
Well, thank you very much. Any brief response to that, Vladimir?
Yes, not a little more than brief. I'm sorry. First of all, thank you very much for all what you've done to me to create this universe created particles. The second very important point, I work on this model 24 years. I have so many results extra. I tried during this 8 presentation to put the most important, the sum of them. I can give additional 8, at least 8 additional presentations to talk about something else. As for the magnetism, I didn't touch even because, of course, I know about it. Of course, I have published paper about the magnetism in the cosmos and so on and so on. I will send you this paper published maybe 3, 4, 5 years ago. I don't know how many years ago. It is too much. That's why, I tried to put as much as possible information in 8 presentations, and I didn't succeed with magnetism because it was too much. Maybe the next presentation will be about magnetism. But what is important, is very important. At the very end of my presentation, I told it's high time to make a paradigm shift in cosmology and classical physics. That's why all the notions, all the definitions, all the theories we have right now, they don't work for us. We must start everything from the beginning. And what I propose, only basis for a new cosmology, a new classical physics. It's not theory. Many times I told only one word, model, ideas, somebody. And for me, it's not somebody. It's the whole community, physical community should develop these ideas and put the basis of cosmology and classical physics on a new basis. That's it, simple like this. I will send you this letter about magnetism. Don't forget, not accidentally, I put this magnetic dipole, so named Dirac of magnetic. Their influence on cosmos is huge. Even currents of these magnetic dipoles, it's a magnetic field in the cosmos. It's my main idea of this point. And I didn't tell anything about it.
Just as a point, everybody has a different idea about what they think is the most important thing to talk about. And that's kind of my view. I think that magnetism is more important a lot more important than some of the other things that you did talk about. So that's just my point of
Okay,
view.
that's a well taken point, Harry. And actually, whether one agrees with that or not, we may persuade Vladimir to come back at a later stage and give us a talk,
All right.
and we may direct him, and he may agree on magnetism.
What I would like to do, I just want to propose this. I'm sure Roger Anderton won't like this idea, but I would like to have some informal discussions on the alternative Saturdays with Vladimir about Vladimir's theory, because I think there's a lot of questions. I have a lot of questions, a lot of things I'd like to learn a little bit more about. And the opportunity to talk face to face is not that frequent. So could we schedule some informal discussions on Saturday mornings, during the alternative weeks? Perhaps we could do that. And I know that Roger Anderton wants to talk on Sundays, so maybe we could do it on Sundays if people are available. Anyway, that's my last of my comments.
Okay, we'll have to negotiate that separately, and we can have a discussion about it, and with Roger and with David and so on. It's somewhat out of my hands, but I'd certainly be happy to give my opinion on it.
Oh yeah.
So thanks very much for that,
Great
Harry.
idea, Harry. Thank you so much. It's a great idea. I wanna questions from you guys. And why I came to you, let me tell you. You're dissidents, don't forget, because this conservative high rank, physicists, there is no choice for me, because they will never accept what I'm talking about. And dissidents, at least you have some flexible mind and you can follow my ideas, because you are not following the maybe Big Bang model at all. That's why, I'm with the right guys right now. And if I cannot convince you, then there is no way for me to go further. Sorry.
Well, it's a two-way. Harry's gone off. I was just about to ask him if that was the end. Well, it's a two-way affair, and thank you for those kind words and indicating that you find our audience responsive. So it's a two-way affair. But the time, as usual, has caught up with us, and I'm afraid we're going to have to summarize now. I'd like to give Vladimir a further chance. He's probably said it all, but just to summarize, before I want to say a few things before closing the meeting. So, Vladimir, I'm going to give you the floor for a few minutes, if you wish.
Yes, it will be very short. First of all, I would like to thank you to be a great moderator. You've done a great job, Ian. Thank you very much. I told you many times about atmosphere, about questions, about everything what I had during 8 presentations. Many thanks to Nick, who proposed me to make these presentations, who read them, who made valuable comments and suggestions for my presentation. It helped me a lot to do it the right way. I tried maybe too much, and he told me from the beginning, it will be too much. That's why read your papers. Even reading, it's too much for people. Maybe discussion will be better. It's a very good idea of Harry. Special thanks to Harry with our communication, private communication. He initiated me to rethink about the dark matter notion and to introduce a new notion that it's matching my model, universe created matter. It's the main advantage for me during these eight presentations, because right now my understanding of what I propose even better due to Harry. And of course, I'm very happy with Harry, I told you, and I was very happy with participants of these presentations, their questions. Thank you very much, guys, for all of them. I will be back sometimes, and I will be more than happy to answer all your questions. You can contact me directly by my email address. You can find in any presentation on the top of all the presentations. Thank you very much, guys, and good luck to you, to all of you. Bye now.
Well, thank you so much again. And it devolves upon me to close the session and to say a few words. Well, it's quite obvious that Vladimir is very receptive to any guidance at all, and I do know that Nick guided him very much initially and persuaded him to undertake this marathon session as well, and that Harry gave some specific technical advice which helped him along the way, including his ditching of the term dark matter. And he was very kind in mentioning any of my small endeavors, which I think can easily be exaggerated. But the important thing is that the person responsible for this is actually Vladimir. He's done a marathon amount of work, and he's presented this in written form. We could go through it completely. We have now, as I say, a record for posterity, that people can go back and go through these various parts and say, oh, goodness me, what did he say about the Milky Way or something? Let's have a look at that. Or what did he say about ball lightning or something like that? It's all there, thankfully, permanently on the system. And it's basically, as I said, I think at the beginning of these sessions, it's basically something like a course that could be held in one of the colleges or something like this, where one could get a course as to how this model is applied to various aspects of the universe, and one could maybe pay a lot of money and attend the course and question the lecture and so on. So we've had the opportunity. Vladimir has been very gracious in giving us his time, getting up at 7 a.m. In the west coast of the United States to give these talks every 2 weeks. I found it fascinating, actually, as well, and it's not the end of it. And thank you very much, Denny, for raising those points as well, because there might appear to be a bit of a contradiction between some of the things said and some of the things maybe I've said. Or here's another thing, Jim Morrison, he says, GPS pseudo range correction detects the local ether every day. So I don't see these things as being killing the idea. It's really spurring us on to maybe coordinating ideas. The same thing with Jim Keane here in maybe his complementary work on the quantum level and the macroscopic level of what Vladimir has been dealing with. So all I can say is, having come to the end of this very, very long, very, very interesting session, it's been evidenced by the amount of contributions we've had. I've neglected a lot of the conversation to and fro on the media, which we actually we promote. We've no problem with that at all, but unfortunately we don't have time to get into it. But Vladimir has indicated that he is available for comments at any further stage. So if any people want to take any of these matters up further that we weren't able to thrash out fully in the sessions themselves, please feel free to do so. So thank you all very, very much again. We're just over the time. There's one more comment which has come in, but it just says thank you very much, and you're all very welcome, and so on. Yeah, the private chat, a few more comments in this is fine. Okay. So thank you very much for making my job so interesting. I mean, obviously, I wouldn't be doing this for the goodness of my health. I'm so interested in hearing all the views, how Vladimir's model is applied to various aspects of physics. Vladimir was in touch with me many, many years ago, and it was a bit opaque because of Harry says there's maybe so much information there, but I've learned a lot, and I'm going to give this a lot more thought in the coming months and perhaps even years. So I'll wish you all a very, very good day wherever you are. Thank you for your participation again. Thank you very much, Vladimir, for having borne with us for so long in reaching the end of this, and everybody else as well. So I'll end the stream now. Good day to you all. Thank you again.